All right, this is example 5.4.3. This is a natural extension that I usually get after presenting example 5.4.2. It says, okay, well, wait a second. What if I were to take all 7 billion people and I were to pile them in one place? And they would say, okay, would that be enough to make the Earth move? And so you say, okay, well, let's take a look at it. Assuming there's 7 billion people on the planet, okay? So you have 7 billion people, which is 7 times 10 to the 9th, and you say we're going to assume an average mass of 75 kilograms. It's like 150, 160 pounds, which is probably about right when you account for children and different countries have different size people. So 75 kilograms. Those two numbers multiplied together represent the mass of this object, whatever's pulling the Earth whatever direction. Now that right there needs to be multiplied by gravity to figure out the gravitational force. Once I do that, you realize that you are going to get a large number. 7 times 10 to the 9th times 75 times 9.8 actually gives a very large value. 5.145 times 10 to the 12th newtons, which is a very, very, very large force. 5.1 trillion newtons. But remember, that has to equal mass times acceleration on the other side. So this has to equal the mass of the Earth times its acceleration. When you look at it from this perspective and you realize dividing out, you have to divide this number, this 5 trillion divided by 5.98 times 10 to the 24th, you realize that the acceleration value is 8.6 times 10 to the negative 13th meters per second squared. Okay, this is an extremely small value. Just to put it in perspective, one atom, a single hydrogen atom across, is 1 times 10 to the minus 10th. Okay, so just to kind of scale this down a little bit further, if you were to cut this right here, the distance of an atom into 1,000 pieces, okay, so this right here would represent 1/1000th the distance across a single atom. You wouldn't even get one of those as far as your acceleration if you stack all 7 billion people on the planet. So what you should take away from this is, of course, that the mass of the Earth is very, very, very large.